Right. So number 10. Find the LCM of 15, 25, and 35. This question was taken from lowest common multiple, that's the topic. Now, for the solution, we shall explore two methods, like I said at the beginning of the presentation. The first method is a table method, where you are trying to look for factors that can divide at least one of the three numbers that we are considering. Now, 3 is the smallest factor that we can think of in this problem, and 3 can divide 15. 3 in 15 therefore will give us 5. 3 cannot divide 25, so we leave it that way. The same with 35. Next, we think of another factor that can divide at least one of them. So we have 5. 5 can divide 5 to give us 1. 5 in 25 is 5. 5 in 35 is 7. Next, we consider the next factor, which is 5. 5 can divide 5 to give us 1. 5 can divide 7, so we repeat 7. And finally, 7 will divide 7 to give us 1. Therefore, our LCM is the product of all the factors that we have used. That is 3 times 5 times 5 times 7, which will give us 5, 2, 5. The other alternative method is to write each number as a product of its prime factors. Now, 15 can be written as 3 times 5, 25 can be written as 5 times 5, 35 can be written as 5 times 7. And so, in picking the factors you need, this is the rule. Check every single factor that appears in all of these expressions and pick the case where it appears the most. For example, 3 is the smallest factor here. It appeared only in 15 and it appears only once. Okay, so we take only 1 3. 5 appeared in the 3 numbers, but it appears more in 25, and with that we have 2 of it. Or you simply say the highest power, which is 5 raised to power 2. And so you take the whole of 5 raised to power 2, or 5 times 5, as your factor there that you are going to consider. And finally we look at 7. 7 appeared only once, and then we have that 7 taken here. Therefore, our LCM is now the product of 3 times 5 in 2 places, or 5 times 5, and then 7, which will give us the same answer, which is 525. Points to note: 525 is the smallest number that 15, 25, and 35 can all divide without remainder. So the LCM is the smallest number that all the numbers in question can divide without remainder. Question number 11. Find the HCF of 186, 310, and 434. Now, in the case of this problem, we are dealing with HCF. HCF means highest common factor, and that's where we are getting this from, the topic. Now, you look for, in this case, a factor that can divide the 3 numbers at a time, unlike LCM, where it just needs to divide only one of them. In this case, it must divide the 3 at a time. Now, the smallest we can think of here is 2. So 2 in 186 is 93, 2 in 310 is 155, and 2 in 434 is 217. Now, when we consider other prime factors like 3, 5, 7, and so on, 11, 13, we discover that the next prime factor that can divide the 3 numbers is 31. Okay, it's 31. And if you check 31 in 93 is simply, 31 in 93 is going to give us 3. 31 in 155 is 5. 31 in 217, 7. Therefore, 3, 5, 7 can no longer be divided by a common factor. Therefore, our HCF is simply 2 times 31. Okay, and that's 62. The other way to do it is You can write each number as the product of prime factors, just the way we did for LCM. The only difference here is that we are not picking each factor, the highest appearance of each factor. Instead, the one that is common to the product of the common prime factors 2 and 31.